Okay, so we are now looking at polynomial functions and their graphs. So a polynomial function of degree n, we're going to let n be a non-negative integer, and then as a sub n, then a sub n minus 1, all the way down to a sub 0 are real numbers. The function is defined looking like this. What we really are worried about is the coefficient of the variable to the highest power, which we call the leading coefficient. The polynomial functions have a positive integer degree. That means there's no negatives or fractions in the exponent. So let's look at some examples. So if f of x is equal to negative 3x to the fifth plus the square root of 2x squared plus 4, our degree will actually be 5 because that is the highest degree. If g of x is equal to negative 3x to the fourth times x minus 2 times x plus 3, the degree is actually 6 because this is all multiplication. You'll have a degree of 1 here, a degree of 1 here, so 1 plus 4 gets you 6. Now, it's not a polynomial function if it has some issues. So, the exponents cannot be a fraction and they cannot be negative. So if we have negative 3 this times the square root of x plus square root of 2 times x squared plus 4, you'll notice this is very similar to the original one. That part is okay, but this part here, the square root of x, remember that's the same thing as x to the 1/2 power. Well, that's a fractional exponent, so it's not a polynomial function. This one is also very similar, except we have negative 3 divided by x squared. If we bring that x squared up, it becomes negative 3 times x to the negative 2. So that's not a polynomial function because your exponents have to be positive and they have to be an integer. So when we're looking at the graphs of polynomial functions, they are going to be smooth and continuous. So they're going to be smooth and continue on. Not a polynomial function. It's going to have sharp corners. So this would be like a sharp corner, or they're going to be discontinuous at a certain point. So smooth and continuous, sharp corners are discontinuous, not a function, totally polynomial function. So you need to know that so that you're aware of that. All right, next part, leading coefficient test. As x increases or decreases with that bound, the graph of the polynomial function, looking like that, eventually rises or falls. So if we have an odd function, our odd functions either go like this or they're going to go down like this. It doesn't matter how many bumpies are in the middle. We care what way the graphs are going. So when it is a positive a out front, the a sub n, so the leading coefficient, if it is positive, then it's going to rise to the right and fall to the left. Now again, as in previous sections, I'm only worried about drawing the arrows. You don't have to write all the words. If it's going to be a negative that's out front, leading coefficient, then it's going to go down this way. And for the even ones, so think about odds. They're going to go opposite ways. They're either going to go opposite this way or opposite that way. The even ones are usually like even Steven. They both go up or they both are going to come down. And if it's a positive like x squared, it goes up. If it's a negative, it's going to come down. So with this, what you always want to look at is whether or not it is positive or negative first. We're going to figure out if it's going to go up or if it's going to go down on the right side. If it's an odd function and it is positive, then it's going to rise and the other one's going to go the opposite. On the odd, if it's negative, we know it's going to come down and the other one's going to go the opposite. On an even function, then we're looking at if it's positive, it goes up, so the other one will go up. If it's negative, it's going to go down, and that means the other one's going to go down. So you're going to have things that look like this. So this is what I'm looking for when you're telling me the end behavior. So as I'm stating, it can be easier to choose the end behavior of the right side of the graph first and then do the left. So let's go do some examples of this. So example 1, we're looking at f of x is equal to x cubed plus 3x squared minus x minus 3. And I want to do the leading coefficient test. So the first thing I have to do is, what degree is it? Well, the degree is going to be our highest degree here, which is going to be 3. And that tells us that it's odd. And that's what we really care about, is it an odd graph or an even graph? So it's going to be odd on that leading coefficient part. It's not necessarily an odd function, because we've learned that before. We're just looking at that initial 1. So with the odd, and we need to know what the leading coefficient is. So the leading coefficient in this case is going to be 1, but what we really care about is that it's positive. So if it's positive, that means it's going to go up. And because it's odd, it will go opposite. So I'm just looking for the 2 arrows. So example 2. If we're looking at f of x is equal to x to the 4th minus 4x squared, we're looking for the degree. The degree is, the highest degree is 4 on our leading coefficient, so 4, which we care that it is even, and the leading coefficient again is a 1, because if we don't see another number, it's always 1, and we care that it is positive. Because it's positive, it goes up. Because it's even, it goes the same way, so it's also up. Example 3. F of x is equal to negative 4x cubed times x minus 1 squared times x plus 5. Now, don't multiply this all out. Just add the exponents. So our degree, because it's all multiplication, is going to be 3 plus 2 plus 1. So the 3, the 2, and this has a 1, because all the 1's on the inside are 1. So 3 plus 2 plus 1 will get us 6, which tells us this is even. The leading coefficient is equal to negative 4, but what we care about is that it is negative. The negative tells us it goes down. The even tells us it goes the same way. All right, so let's go look at some more stuff we need to know. So multiplicities and X-intercepts. So the general form is x minus r to the k, where r is the root, k is the multiplicity, and it appears as x-intercepts on the graph, called roots or solutions. They're also x-intercepts. So even will do 2 things. So if you think of an even number, the smallest even number you think about is 2. Well, a 2, we're going to do 2 things. It will touch and turn. A degree that is odd means it's going to do 1 thing, like the lowest odd number of 1 when we're looking at positive ones. And that tells me it's going to cross. So we are going to find the zeros by setting f of x equal to 0. Think about we're finding x-intercepts. We're going to solve for x. And the maximum number of turning points is n minus 1, where n is the degree of the polynomial function. So let's go find some zeros. So we're going to find the zeros and their multiplicities. So if we have f of x is equal to x cubed plus 3x squared minus x minus 3. This is that grouping of 4 that we have to split and factor by grouping. So we'll just split it in half. So we also need to set that equal to 0. We should have done that first, but that's okay. 0 cubed plus 3x squared minus x minus 3. So once we've set it equal to 0, then we'll split it in half. So on the first part, I can factor out a common factor of x squared and end up with x plus 3. And then on the second part, the only thing they have in common is a 1. But it will be negative because I'm going to bring down that sign and factor out a 1, and I'm going to end up with x plus 3, because you're actually factoring out a negative 1. Now we know we did it correct because those match. If they don't match, you're going to have to go back. So 0 will be equal to that x plus 3 because that's our common factor we factored out, times x squared minus 1. It doesn't matter. You could put the x squared minus 1 first. It doesn't matter. Now, the next thing we're going to do is set each part equal to 0. So x plus 3 equals 0, and x squared minus 1 equals 0. So x plus 3 equals 0 will get us x equal to negative 3. This part you can solve a couple of ways. You can either move the 1 over and take the square root property, or you can factor it because it's the difference of squares. I'm going to just move it over so we can practice that square root property. We get x squared equal to 1, taking the square root of both sides. I get x is equal to plus or minus the square root of 1 will be 1. So that means it's x plus 1 and x equals positive 1 and x equals negative 1. So our zeros are going to be x equal to negative 3, x equal to 1, and x equal to negative 1. Now, I need to figure out what the multiplicities are. So in this case, we're looking at what's the x value. The x value is 1. This x value is 1. So we are looking at they're all a multiplicity of 1. So the multiplicity is 1 for each of these. So that tells us our behavior will be crosses. We're talking about it crosses at the x-axis. But I'm okay if we just write crosses so we don't have to write so much. All right, let's go look at example 5. So for example 5, we are looking at f of x equals 1/2 times x plus 1 times 2x minus 3 squared. Well, this one's nice because it's already factored for us. So we're just going to set it equal to 0. Because remember, we're just looking for x-intercepts. Now, the 1/2 doesn't have an x on it, so I don't have to worry about it. So I just have our x plus 1 equals 0, and our 2x minus 3 equals 0. Because you're just going to take what's inside of the parentheses. All right, so this will get us x equal to negative 1. 2x is equal to 3, divide by 2, whoops, and x will be 3/2. Now, what's the multiplicities? Well, on this one, the multiplicity is equal to 1 because that was the exponent on the parenthesis. This, the multiplicity, is 2 because that's what was outside of the parenthesis for the exponent. So this one tells me it's going to cross, and this one is going to touch and turn. So it's going to touch the x-axis, and it's going to turn around. But touch and turn works for me. All right, let's look at another one. Example 6. So f of x is equal to negative 4 times x plus 1/2 squared times x minus 5 cubed. So again, we're going to take our parentheses and set them equal to 0 because there's no x on our leading coefficient there. So x plus 1/2 equals 0, and x minus 5 equals 0. So x will equal negative 1/2, and x will equal 5. On an exam, I expect that you set that equal to 0 because I need to know that you know why and how it gets there. So what's the multiplicity? The multiplicity is 2, and the multiplicity is 3 because there's a 2 and a 3 for our exponent. Well, a multiplicity of 2 tells me it will do 2 things. It's going to touch and turn because it's an even multiplicity. Multiplicity of 3, well, that's an odd number, so it's going to do one thing, and it's going to cross the x-axis. Sorry. All right. Let's go look at graphing a polynomial function. Okay, so graphing a polynomial function. It uses the leading coefficient test to determine the graph's end behavior, so we're going to do that. We'll find the x-intercepts and the Y-intercept. We'll use some symmetry if we need it to help draw our graph. And we can use the maximum number of turning points of the graph, n minus 1, just to check to whether it's drawn correctly. All right. So we're going to move to a new sheet because we're going to have to do several steps. So this will be example 7. So example 7, we're actually going to graph a polynomial function. All right, so we are going to graph f of x equals to x to the 4th minus 2x squared plus 1. So the first thing that we are looking at is that our degree, whether it's positive or negative or even or odd, we're looking at all of our leading coefficient and the degree. So step 1, the degree, the highest degree is 4, which tells us it's even. And our a sub 1 is equal to 1, and it is positive. Remember, we care that it is positive, so it goes up. And even tells me it goes the same way. This helps us, instead of writing rises to the left and rises to the right, this helps me see that my graph will look like this. It's going to have some waves in the middle, but it will look like that. Part 2, let's find our x-intercept by setting our y is equal to 0. All right. So if we're looking at x to the 4th, all right, we're going to change our equation slightly. Somehow my notes changed, but I didn't rewrite the original question. So we're going to just change this slightly. So minus 9x squared. So we're going to go with that because that's what the rest of the notes. So I need to fix that. Sorry about that. All right. So 0 is equal to x to the 4th minus 9x squared. So we need to factor what they have in common here. We could have done that one, but I don't have it all worked out, and it would take some effort to redo that. So, on the fly. All right, so what we have in common here is an x squared. So we'll have x squared minus 9. This will give us some other skills that we can look at. And so this will get us 0 is equal to x squared. Well, x squared minus 9 is the difference of squares. So that'll get us times x plus 3, x minus 3, or x minus 3, x plus 3. It does not matter the order in which you do it. And now we can set each part equal to 0. So x squared equal to 0. To solve that, we're going to use that square root property again. And x will equal plus or minus 0, but when you take the square root of 0, you're only going to get 0. So we can just go to the x equal to 0. But if it was any other number, we'd have to put show all that plus or minus stuff. All right, x plus 3 would become x equals negative 3. And x minus 3, as we move that x to the other side, will become positive 3. So now we're going to look at our multiplicity. The multiplicity here is 2. Here it is 1. And here it is 1. So for a multiplicity of 2, which is an even multiplicity, it will touch and turn. And understand that the intercept is 0, 0. We didn't worry about that before, but we're graphing this, so we need to know what these points look like. This one is going to cross because it has an odd multiplicity, and so will this one. And the point will be negative 3, 0, and 3, 0, because these are x-intercepts. All right, the third part we need to find, will be the Y-intercept. So the Y-intercept is x equal to 0. So y is equal to 0 to the 4th minus 9 times 0 squared. We're just plugging in 0 for our x. Well, that's going to be 0 because both of those will become 0. So our point will be 0, 0. All right, the next thing we're going to look at, we could find the axis of symmetry by plugging in negative x, but on a test question, I'm not going to ask you that. We know it's going to be an even because we can look at the exponents and tell that it's going to be an even axis of symmetry. So it will have y axis symmetry. If they were both odd, we'd know it was at the origin, and if one was odd and one was even, it would be neither. On the test, I'm not going to ask you to algebraically show me that, so I'm going to not do that part here. But we also need to find our max number of turning points. This is something I will ask you on the exam, so you need to know this. It's very simple if you know what it is. It's n minus 1. N is the degree, which we already found, so it's 4 minus 1. It's the highest degree, which will get us 3. So on our graph, we shouldn't have more than 3 turning points, and that's all we're going to use that for. All right, so let's go graph it. Is it actually the step? All right, so let's go graph. So we don't have really big numbers. We have -3 and 3, and we have some zeros, but we don't have anything really huge of what we're graphing. So x and y. I'm going to go 4 on each part. All right, so graphing this, we are graphing at 0, 0, -3, 0, and 3, 0. And our y-intercept is 0, 0, so there's nothing to go with. Now, if we look at those 3 dots, we're like, how do we graph it? I don't know which way it goes. This is where we go back to step 1. We are told that our graph, we figured out at least, our graph should go like this. So we can draw the arrow here, draw the arrow here. But now what do? Well, this is where we look at what happens. Let's start from the from the left and go to the right. So at the -3, we know it crosses. So it's going to cross through that. It's going to have to turn around because it has to go back. It just doesn't turn around at the point. At 0, 0, it's going to touch and turn. So we're going to come down through, come back up and catch that, and touch and turn. And then we know it's also going to cross at +3. So that's why you need to know the arrows and you need to know the behavior so you can sketch the graph. Notice, I'm still not using a calculator here. I didn't use the calculator to do it at any point. I am just sketching it. It doesn't have to be perfect. It just needs to be a sketch. All right, let's go on to the next example. All right, so this will be example 8. And we are looking at f of x is equal to -2 times x minus 1 squared times x plus 2. So, same steps, we're looking at the degree. So our degree is going to be 2 plus 1, which will get us 3, which we care that it is odd. Our a sub n, or our leading coefficient, you can write it as LC, doesn't matter, is -2. And we care that it is negative. The negative tells us it's going to go down, and the odd tells us it will go opposite. So the other one will go that way. It's always easier if you figure this part out than trying to figure out this side first. All right, number 2, X-intercepts. That's where we set y equal to 0. Again, this one's already factored, so all you really need to do is bring down the x minus 1 equals 0 and the x plus 2 equals 0. So x minus 1 equals 0. X will equal 1. X plus 2 will be x is equal to negative 2 when we move them over doing the opposite operation. And now we care what the multiplicity is. So for x minus 1, the multiplicity is 2. And for x plus 2, the multiplicity is 1. So that multiplicity just is asking, how many times does this occur? Well, because of that 2, it would occur twice, because we could separate it out as x minus 1 times x minus 1. All right, so what does that mean? Well, at 2, that's an even 1, so that's going to be touch and turn. And at multiplicity of 1, it's going to cross. So, what does the point look like? Well, that's going to be 1, 0, and this will be negative 2, 0. Third step, we need to find the y-intercept. That's where we set x equal to 0. So y will be equal to negative 2 times 0 minus 1 squared times 0 plus 2. Well, that'll get us negative 2. This will be negative 1 squared times 2. Well, negative 1 squared is 1. And you could put it in the calculator. But it's always good to practice our math skills, but always double check. So negative 2 times 1 times 2 will get us negative 4. So that tells me it's going to be 0, negative 4 for my y-intercept. All right, max number of turning points. Remember, that's n minus 1, and that n is the degree. Our degree was 3, so 3 minus 1 is 2. And on the last one, we didn't talk about that after we did it. So turning points, how many is it turning? So that's where you're looking at. Their max number of turning points will be 3, and this one we're going to have 2. Like, how many times does it change direction? All righty, let's graph it. So, let's see, we don't have big numbers again. We have a negative 4, negative 2, and 1. So if I go to 5 again, we should be okay. I don't look at the maximum number of turning points a whole lot, but it's something that's simple to find if you know what you're doing. So I'm going to ask you to find it on the exam. 1, 2, 3, 4, 5. So, for our graph here, we'll start with our x-intercepts. We're at 1, and we are at negative 2. Our y-intercept is at negative 4. And we know that our graph, the points of our graph, are going to go down on one side and up on the other. So we're going down this way. We know this side will go up like that. And now we're going to look at our behavior. So at the 1 comma, well, let's start from the right. So at from the left, negative 2, 0, it's going to cross. So we know it's going to come down. When it does, you're going to have to come down and catch that y-intercept. So come down, grab it, come back up. As we meet that, it does say it touches and turns, so we are good for the rest of it. Now, if you have like a y-intercept of like negative 25, I'm not going to make negative 25 hash marks. This would be on our test type of thing. I would just make a negative 25, come down, grab it, and come back up. So you don't have to make as many in the future if we're doing something that doesn't all make it nice and easy on a 5-point graph.